Hello friends, welcome to video lecture on engineering mechanics. In our today's session, we learn about the numericals on friction. So here is the problem. Okay, this problem is related with the blocks. Okay, so block W equals to 50 Newton is resting on a horizontal plane. A horizontal force of 10 Newton applied to start the motion of block. Point, the first point coefficient of friction, second point angle of friction, third point resultant reaction. So first of all, we need to form a diagram of the same in this way. So in this way, information with us, a block of 50 Newton weight is resting on a horizontal plane, a horizontal force of 10 Newton. So this force is applied on this block 10 Newton to start the motion of block. Our aim is to find out the coefficient of friction, that is mu, to find mu, then angle of friction, that is phi, and resultant reaction, that is R. Okay, so first of all, draw the free body diagram of the given system. You can draw the free body diagram by considering the motion of this block. So here you can draw the free body diagram of the system in this way. The body diagram of the given block. So for that, just focus on the block. This way, block with us, whose weight will act in downward direction with the magnitude 50 Newton. This force 10 Newton is acting on the block towards the left side. Whenever we apply this 10 Newton force on this block into this direction, the tendency of opposing force, that is nothing but the resisting force, will act on this block in opposite direction of that of applied force. Okay, so this force is nothing but the frictional force. Okay, now because of the weight applied in the downward direction, the normal reaction comes from the bottom of this, whose magnitude with us, just let us consider this one is nothing but the n. Okay, in this way. Now what's about this one? This is nothing but the applied force. This indicates the frictional force. Now this is nothing but the normal reaction. We just focus here. So this indicates the reaction R. So we know the reaction R is nothing but it is the resultant of normal reaction and frictional force. Okay, so my target is to get the value for this one phi R and the coefficient of friction between this both the surfaces. Okay, now for that, first of all, just see the conditions of equilibrium available with us. Now this system is in equilibrium. Initially the system will not move. This block will not move in forward direction. Okay, the block is at rest condition. Because of application of this 10 Newton force, the tendency of this block to move into this direction means the opposite force will act in the reverse direction, whose magnitude right now we'll consider here as F. Okay, now once the system is drawn by us, free body diagram drawn by us, now apply the conditions of equilibrium. So applying here, applying conditions of equilibrium, we get. Now if you focus on the whatever the arrows here or whatever the forces shown here, the tendency of all these forces to passes through a single point. And in case of the concurrent force system, we know the this one conditions of equilibrium. First one is the summation of f of x equal to 0, and second one summation of f of y equals to 0. These two conditions with us. Okay, now apply these two conditions to this case and just see, you can get the two different equations equation, that is first one, summation of f of x equal to 0. Okay, now focus only on the horizontal forces. For that, it is very important. This force is nothing but the resultant force. The component of this resultant force already with us. This one and this one, these are nothing but the component of this resultant force. Okay, so not necessary to resolve this force. Okay, so already the component of this one and this one available with us. So don't resolve this force. Now what's about this one? This weight will act in downward direction. This force is nothing but the applied force. Now focus only on the horizontal forces. This force running towards right direction, so consider this force as positive. This force running towards the negative direction, consider this force as here negative. Okay, now we know here, since we know F is nothing but the mu into n, this relation already with us. So during the discussion of friction topic, we know the frictional force is directly proportional to the normal reaction. Okay, so if you remove that proportional sign, the mu will comes into picture. Now in this case, this 10 minus 10, what's about this one? Mu into n equals to 0. So in this way I can get the equation number 1. So give equation number 1 for this. Now move towards the next equation. Summation of f of x equals to 0. Focus only on the vertical forces. So this one vertical in the downward direction. Here summation of f of y equals to 0 equals to, just focus on this one, vertical in the downward direction, give the minus sign for this one, vertical in the upward direction, give the plus sign for this. Okay, now if you just see here, straightforward we can get the value for the normal reaction here, that is 50 Newton. So once we get the 50 Newton value for this, then easily you can get the value for mu from equation number 1. Now substituting n equals to 50 Newton in equation 1. So what do we get here? If I substitute the value for the n equals to 50 Newton, therefore mu into n with us 50 minus 10 equate with the 0. So already this relation with us. Here only our aim is here we have to just substitute the value of n here and see the value for the mu. Here we can get the value for mu in this way. Mu equals to 10 divided by 50. So if you solve this, we can get the 0.2. So coefficient of the friction we can get as 0.2. The answer for next point. Okay. So if you just see, our target is to find out the value for y. Okay, here already we get the normal reaction. Here already we get the coefficient of friction. Now the angle of friction, that is phi. For that we know y is nothing but the tan inverse of mu. This relation already we have seen during the discussion of angle of friction topic. So in this case we know the value for the mu. Just substitute here. Do the calculations with the help of calculator. Now just get the value for the tan inverse of 0.2 and get phi equals to 11.309 degree. So this is nothing but the angle of friction. Okay. Now my next target is to find out the resultant reaction, that is R. We know resultant R is nothing but square root of f square plus n square. I can get that f square plus n square. If you focus on this freeboard diagram, here already this R indicate the resultant of this frictional resistance force and this one normal reaction. So R is nothing but it is the square root of f square plus n square. What's about the value for the f square? So already we know the relation between that f and n, mu into n bracket square plus n square. In this we can write the same. Okay, so we know the value for the mu. Substitute here, multiply by n already calculated by us in the this step. Okay, just substitute here the value for the n with us 50 whole bracket square, n with us 50. Now solve this for the r. After solving, you can get the r equals to this here square root of 0.2 multiplied by 50, this into bracket like this, square of this plus 50 square, can get the value for the r equals to 50.99 Newton. The answer for the next point. Clearly mention your answer here. Make the list of the various points. First one is about the coefficient of friction. Just mention mu equals to 0.2. Then next one is about the angle of friction, that is phi equals to 11.309 degree. Then r equals to 50.99 Newton. This is about the answer for the next point. Let us start with the next problem. A 500 Newton block is kept on a rough horizontal surface having mu s equals to 0.3 and mu k equals to 0.2. Force P is applied as shown in figure. Determine P for the motion to just impend. Okay. Now first of all, draw the free body diagram of the given system. Here you can mention in this way, free body diagram of given block, or we can just say simply, we can just say FBD. Here imagine here in this way, the block whose weight with 1500 Newton. Because of the weight in the downward direction, the normal reaction comes into picture, whose magnitude with us n. Now say on this block one force is applied here whose magnitude with us P, that makes an angle 30 degree. At the same time, just get the component of this P, one towards horizontal direction, another towards vertical direction. What's about the component of this one? P cos of 30. What's about the vertical component here? P sine of 30 in this way. Now if you just say the tendency of this block to move towards this direction, because the applied force is towards the right direction, means of course the moment of the block will take place towards the right direction. Okay, means the opposition will occurs here. So this force is nothing but here F force. Okay, remember that this force, resisting force, is in between the block and this one, this surface. So one can show this force here instead of showing this force here. Okay, this is the correct actually position for that force F. Now if you just see here, the force F with us here, normal reaction with us here. Okay, now my target is to get the value for this one P. For that, if I apply the conditions of equilibrium for this case, then I can easily get the value for the same. Now apply the conditions of equilibrium. Applying conditions of equilibrium, we get, again if you just see, the line of action of all the points passes through single point. Okay, so this is the case of concurrent force system. In case of concurrent force system, we know the two conditions of equilibrium with us, that is summation of f of x equal to 0 and summation of f of y equals to 0. So apply this condition and this condition to this case. Okay, now focus only on the this one, horizontal forces. What's about this one? summation of all the forces along the horizontal direction must be equals to 0 for the equilibrium condition of this block. Now focus only on the horizontal forces. This force running towards negative side. Okay, just consider this force as minus. Okay, so minus F is written here. Then what's about this one? This force running towards right direction, so consider this force as positive. So P cos of 30 in this way. The two forces with us, only two forces with us. Okay, that two forces we have considered. Now what's about this F? So as per our previous discussion, this F is nothing but the frictional force. This frictional force is directly proportional with the normal reaction. Okay, so this concepts already we have studied. So if I remove this proportional sign, then mu will comes into picture. Now to focus on the problem given here, there are two different values of the mu with us. Horizontal surface having mu s equals to 0.3 and mu k equals to 0.2. Now this point is very important one, and these two values are important one. Which value we have to consider for the mu? Now here just see, determine the p for motion to just impend, means when just motion starts. Okay, means we just see during this one the highest value corresponding to that limiting frictional force is required, or maximum force is required to bring this block into motion. Means we have to consider the mu s instead of mu k. Mu k is nothing but when the block comes into motion, then we can use the this one mu k. Mu k indicate here coefficient of kinetic friction. Okay, and this mu s indicate here coefficient of static friction. Okay, means we need to consider the coefficient of static friction. Okay, so here you just give the suffix as mu s. So you can use this one mu s, mu s term. Okay, instead of this one mu k. What's about this mu s? Mu s with us 0.3 already given in the problem. 0.3. Consider this 0.3 multiplied by n in this way. Now focus on equation number 1. So equation 1 will modify it in this way. Summation of f of x equal to 0 equals to, what's about this one? 0.3 into n is nothing but here f to the minus sign here, plus p into cos of 30. Give equation number 2 for this. Now move towards next equation, that is summation of f of y equals to 0. Summation of f of y equals to 0. So what's about the vertical forces? Focus here. 1 500 adds in vertical downward direction with the minus sign for this one vertical in the upward direction with the plus sign for this. The next force with us p sine of 30 vertically in the upward direction. So consider this force as positive, p sine of 30 in this way. Now this equation number 2 with us in terms of n and p. This also equation available with us in terms of n and p. Okay, I'll just write this equation this way: n plus p into sine of 30. Take this one 1500 towards the another side of this equation, so we can get the equation number 3. Now solve equation number 2 and equation number 3. Easily you can get our answer. Now in this way, just use the equation mode. So here is the simple actually equation with us: a n x plus b 1 y plus c n. Okay, or simultaneous equation you can just say for that. Okay, first equation, this equation with us and this equation with us. Okay, so coefficient of this n, for that I'll just consider the equation number 1. So here the coefficient of the first term with us minus 0.3. Just enter this value. For that use this one equal to button. Okay, so next to this one, the coefficient of the p term with us cos of 30. Cos of 30, just enter value here. Then if you just look towards the right side of this one, or look towards the another side of this equation, 0 with us, just substitute the value for constant as 0. Okay, the next one, the coefficient of this n with us as 1. So substitute the n equals to 1 here. Press equal to button. Then next one, the coefficient of the p with us sine of 30. Just here coefficient of the P with us sine of 30, just substitute here sine of 30. And if you look towards the right side of this one, 1500, this term with us as constant term, this one equal to button, again press this equal to button, you can get the unknown value for the first term. So first term with us as n equals to 1278.48 in this one, and second one, just focus here, I can get the value for the p equals to 442.90. so this is the answer for the p. Our target is to find out the value for the force P. Okay, here the force P is applied and determine the P for the motion to just impede. So this is the answer for the P. P equals to 442.90 Newton. Let us start with the next problem. The upper block is tied to a vertical wall by a wire. Determine the horizontal force P required to just pull the lower block. Coefficient of friction for all surfaces is 0.3. Now the system is given in this way. This block is mounted on this block, okay, and this block is mounted on the plane surface. So this block is tied from one end to a vertical wall by a wire. Now see this information with us. With the help of this we can get the angle theta. Okay, now first of all, our aim is to draw the free body diagram for the given system by isolating every part, okay, or every block from one another. Okay, so if you just focus on the first block, just draw the diagram for that first block in this way. Isolate that block from the second one. I'll just mention here free body diagram of the given blocks. Okay, for that whatever the weight of this block, that will add in downward direction, whose magnitude with us 500 Newton. Okay, so another block is here. Simultaneously you have to draw the diagram for both the blocks so that we can come to know where is the motion of the bottom block and how the frictional force will comes into picture. Okay, now the weight of this block is also at in downward direction with the magnitude 1000 Newton. Okay, now see this P force is applied on this block in such a way that the motion just begin. Okay, so tendency of this force to bring or to push this block towards this direction. At the same time, the reaction between this one and this one, so this is nothing but the normal reaction that will comes from the exact normal to this surface. Okay, this reaction will just consider the reaction between this surface and this one is nothing but here just consider as n1. Now this force is applied towards this direction, and in the reverse direction we can get here the frictional force. Okay, so this is nothing but, if I consider this one is nothing but the F1 in this one. Now this block is also contact with this block, means whenever the motion of this block takes place towards this direction, the resistance occurs between the motion of this block and this one in opposite direction. Okay? Opposite direction of the applied force, means here in this case also we can get, this is nothing but the frictional force between this surface and this surface, this block and this block, upper side of this block and bottom side of this block. So here we can just consider the frictional force between these two surfaces is nothing but the F2. So next one, the opposite of this F2, here we can get the magnitude for that F2, and this one is same but in opposite direction. Why? Because if we just pull this one into this direction, this force comes into this direction and opposite of this one must be here. So what's about next one? If this force, whatever the block of whatever the weight of this one acts in downward direction, means automatically the normal reaction comes into picture. What's about that normal direction between this surface and this one? This is nothing but the n2. Let us consider this normal direction between this surface and this one is nothing but the n2. Now what's about the next one? Here in this case, the wire is tied between this block and vertical wall. So this, if I break this wire here, if I cut this wire here, so you have to show that in terms of tension. So tension I'll just show by T. So from this diagram, you can easily first of all get the value for theta. So what's about the theta? Since tan of theta equals to front side with us 3, this side with us 4. What's about the theta? Theta is nothing but the tan inverse of 3 by 4. After solving, we can get tan inverse of 3 by 4, so equals to 36.86. So theta with us 36.86. If you just see the next decimal place is greater than 0.5, so we can increase the previous by 0.1. So here in this way you can get that angle 36.87. So value for the theta with us 36.87 degree. So at the same time you can just resolve this inclined force into its component in this way. So this component must be T cos of 36.87 and this component must be T sine of 36.87 in this way. Now all the forces shown by us, also the name for all the forces are written here. Now in case of this F2 force, frictional force, we know that frictional force is proportional with the normal direction. Okay? So for all surfaces, the value for the coefficient of friction is given 0.3. We can just get this one in this way, mu into n1, like this one. So as this F is directly proportional to n with respect to this surface, F1 force with us, we can easily write for this one as F1 equals to mu into n1. So for this case we can write mu into n2 because the normal direction between this surface and this one is nothing but the n2. If you just see this surface and this one, the reaction of this surface will occur on this one and reaction of this one will occur here. So you need to consider this and this one in opposite direction to each other. So here also that n2 will comes into picture. Okay, now all the forces shown by us, apply the conditions of equilibrium for this block and for this block separate. Now apply the conditions for the block, or choose the block in a such way that we can just get the minimum values. Okay, the minimum unknowns are there. Now if I apply here the conditions of equilibrium for block number A, now just see here what do we get here. Applying conditions of equilibrium to block A. Now for that, just focus here the block A with us here. Now the two conditions with us, summation of f of x equal to 0 and second one summation of f of y equals to 0. Now focus on the first one, summation of f of x equal to 0. For that, concentrate only on the horizontal forces. Here is the first force running towards negative side of that x-axis, means give the negative sign for this one. And next force is here mu into n2. This force with us, this force with us. The two forces with us, we can easily get that relation here. T cos of 36.87, this force we have considered. Then next force is here running towards right direction. Consider this force as positive. Instead of writing F2, we can replace that F2 by mu into n2, like this. Now here in this case you can get the equation number 1. So before that, again we can just simplify this equation in this way. 0 equals to minus t into cos of 36.87 We know the value for the mu as 0.3 into n2. So give equation number 1 for this. Now move towards the next one. Summation of f of y equals to 0. Focus on the vertical forces with respect to block number A only. So here the vertical force with us, T sine of 36.87, T sine of 36.87 vertically in the upward direction. Consider this force as positive. This one 500 Newton force vertically in the downward direction. So give the minus sign for this one. Next one with us N2 vertically in the upward direction. Just give the minus, sorry, vertically in the upward direction for this one. This force to the positive sign for this. Now three forces with us. One, count them. 1, 2, 3. Only three forces with us. All the three forces we have considered here. Now if you focus on the previous equation and this equation, the two unknowns with us, T and N2. Write this equation in a such way that you can solve that equation on the calculator easily. Here the T term we have written first, and then N2 term we have written here. So what's about the N2? Our aim is to get the value for here T and N2. Equation number 2 for this one. So solve equation number 1 and equation number 2. Easily we can get the value for N2 as well as T. Here is equation number 5. 1, the coefficient of this first term with us, minus cos of 36.87, press equal to button. Automatically cursor will move towards the next position. Here 0.3 with us, coefficient of N2 with us 0.3, press equal to button. 0 constant term with us, press 0 button. Okay, cursor automatically move towards the next one. Then here is the first term with us. Don't substitute the value for 500 here because the coefficient of the first term is here. Okay, this is nothing but the constant term. Okay, so you have to write the constant value for the constant term at the third place here. Okay, so coefficient of the first term with us, sine of 36.87, press equal to button. The coefficient of N2 term with us 1, so substitute 1 here. Then coefficient, this one constant term with us 500, substitute here, press equal to button, again press equal to button. So the first here, after solving, you can get T equals to, so X indicate the first unknown value, that is T 153.06 Newton. If you again press the equal to button, then we can get the value for N2. So second actually unknown value, and N2 equals to 408.16 in this one. The unit for this one as Newton. Now apply the conditions of equilibrium for the next block. Next block is here. My target is to get the value for this one P. For that, if I just focus on the two equations with us, just applying conditions of equilibrium to block B. Now focus on the block B. Just see the block B, here the two forces with us, N1, N2, and this one. I apply summation of f of y equals 0 as first condition, you can easily get the value for N1. So N1 actually proportional with this F1. Okay, so already the value for this one N2 we get from the previous relation, you can easily get the value for this one P. So I'll just use this equation as first. Okay, as per our convenience, we can use the equation number summation of f of x equal to 0 as first, or summation of f of y as first. Now just focus only on the vertical forces. N2 vertically in the downward direction to the minus sign here, 100 Newton vertically in the downward direction to the minus sign, N1 with us vertically in the upward direction to the plus sign for this one. Already the value for the N2 with us, substitute here and get the value for N1. So N2 with us 408.16 plus 1000. If I take this N1 towards, if I write this N1 towards one side, and if I take this towards this term towards the another side, automatically the sign will changes. So in this case, we can get the value for N1 as 1408.16 Newton. Now move towards next relation, that is summation of f of x equal to 0 equals to, focus only on the original forces. So here is the first force, here is the next force, here is the next force. Okay, so first force with us whose magnitude with us mu with us 0.3 and 1. Now next force is here F2, to the minus sign for this one, minus mu means here 0.3 multiplied by N2. Both actually forces running towards the negative side, that's why the minus sign is given here. The next one P force with us to the plus sign for this one and equate with the 0. So already the value for the N1 and value for the N2 with us. Just substitute here and solve this equation for the P. Therefore equals to 0.3 multiplied by N1 with us 1408.16 plus 0.3 multiplied by 408.16. Okay, if you solve this, automatically we can get the answer for the P. So P is nothing but here 0.3 multiplied by 1408.16 plus 0.3 multiplied by 408.16 this way. Answer for the P with us 544.896 Newton. I hope the problems on friction topic related with the block clear to you.